Is Earth, right now, being watched by alien technology? Something disguised as, well, a giant cosmic snowball. That's the really wild question at the center of our deep dive today. It's all about the fastest and maybe the strangest visitor our solar system has ever seen.
Welcome to the deep dive.
Yeah.
Today we're looking at Comet 3I Atlas. It was just discovered, relatively speaking, and there's already this stack of reports, theories, claims. Our job is to sort through it all. We're unpacking a pretty intense scientific debate. On one side, you have the consensus view it's a natural comet, maybe a bit weird, but natural. And on the other, a very controversial idea, that it's actually alien tech.
Okay, let's get the basics down first. This thing, 3-eyed Atlas, found July 2025. And it is seriously fast, like unbelievably fast.
Absolutely. It's only the third interstellar object we've ever confirmed. Yeah. And the speed, over 130,000 miles an hour, that's more than 209,000 kilometers per hour.
Wow. So fastest visitor on record.
By far. And the defining thing really is its path. It's got what astronomers call an extreme hyperbolic orbit. The eccentricity is 6.137.
Okay, eccentricity, 6.137. What does that actually mean for us non-astronomers?
It means it's definitely just passing through. It came from interstellar space, it's swinging by, and it is absolutely never coming back. A one-shot deal for us to study it.
Right. And timing-wise, its closest pass to the sun, perihelion, that just happened, right?
Yeah.
Late October 2025.
That's correct. Just a few days ago.
And crucially, for anyone, maybe getting a little nervous, it's completely safe. No impact risk.
Oh, none whatsoever. It's passing about 1.8 AU from Earth in December.
And an AU is the Earth-Sun distance, so 1.8 times that far away.
Exactly. Way out past Mars's orbit. So totally safe distance-wise, but it's how it's moving and maybe what it's made of that's got everyone talking.
Okay, let's dive into that controversy then, the alien technology side. We have to start with Avi Loeb, right?
Yes, Professor Avi Loeb from Harvard, former chair of astronomy there, founder of the Galileo Project. People might remember him from the Oumuamua debate.
The first interstellar object. He was pushing the artificial origin idea then, too.
He was. And he's back at it with 3I Atlas, proposing this Trojan Horse idea.
A Trojan horse, like disguised.
Exactly. His hypothesis is, what if it looks like a comet to, avoid scrutiny, but it's actually some kind of technological artifact, maybe even a mothership, releasing smaller probes as it cruises through our system.
That's a bold claim. What's he basing it on?
Well, he starts with statistics, numbers that just seem unlikely. He gave it a 4 out of 10 on his own Loeb scale for potential artificiality. The first big thing is its orbital alignment.
Alignment? How so?
Its path, its trajectory, lines up within just 5 degrees of the ecliptic plane. That's the sort of flat disk where all our planets orbit the sun.
Okay, and why is that weird for an interstellar visitor?
Well, think about it. Something coming from deep space randomly tumbling in, the chances of it just happening to line up so neatly with our solar system's specific plane? Loeb's calculation puts the probability at only 0.2%. It's just suspiciously neat.
0.2%. Okay, that does sound low, but is that the main statistical point?
No, it gets even more specific. He argues the trajectory seems almost targeted, like it was calibrated to pass close by Mars, Venus, and Jupiter, while also being perfectly placed for observation from Earth, right around perihelion, its closest point to the sun.
Wait, hitting multiple targets like that, like a planned trajectory?
That's the core of his statistical argument. For a random object to just happen to make those specific close passes and be observable at just the right time, according to Loeb's math, the probability of that happening by chance is just 0.0005%.
0.0005%. That's tiny.
It's incredibly small. 5 chances in 100,000, basically. Random space rocks, he argues, just don't thread that kind of needle through the solar system.
Okay, that math is definitely eye-opening. It forces you to look harder, at least. But statistical arguments can sometimes be tricky, right?
Yeah.
What about actual physical evidence? Things telescopes actually saw.
Right. Moving beyond the math, there were definitely some physical oddities observed. First, this thing called the anti-tail.
Anti-tail, so
Yeah.
Not a normal tail.
Exactly the opposite in a way. During July and August 2025, telescopes saw it ejecting material towards the sun, a sunward jet.
Towards the sun. But don't comets normally have tails pointing away from the sun, pushed by solar wind and radiation?
Precisely. This jet was going the wrong way, which is hard to explain with standard comet physics. It definitely raises questions.
Okay, weird jet. What else?
Second, and this one is potentially huge,
Yeah.
the chemical signature. They detected emissions of nickel tetracarbonyl.
Nickel tetracarbonyl doesn't ring a bell. Is that common in space?
Not at all. Our sources are pretty clear on this. They state it's a compound, quote, only seen in human manufacturing.
Hold on. Only seen in human manufacturing. What is this stuff?
It's this highly toxic, volatile liquid. On Earth, its main use is in something called the Mond process. It's a specific industrial technique for refining nickel to a very high purity. It's complex industrial chemistry.
So finding that out there
Yeah.
suggests something not natural.
It strongly suggests it, yes. Finding that specific complex molecule, especially in detectable amounts, is very hard to explain through known natural astrophysical processes. It points towards, well, manufacturing.
Wow. Okay. If that detection is solid, that's a game changer.
It definitely makes the natural comet explanation much harder. And then there's the acceleration.
Acceleration, like it's
Yeah.
sped up on its own.
It showed what's called non-gravitational acceleration, meaning it changed speed and direction in ways that gravity alone couldn't account for. Now, comets do sometimes do this when uneven jets of gas push them around like tiny rockets.
Right. Outgassing can act like a thruster.
It can. But proponents of the artificial theory argue that when you combine this acceleration with the precise targeting and that weird chemical signature, the whole picture starts to look suspicious.
And it's big, too, right? Much bigger than Umoa.
Oh, yeah. 1,000,000 times more massive. It's a seriously substantial object moving through our system.
Okay, that's a really compelling case for something strange based on math, chemistry, behavior. But what about the other side? The scientific consensus.
Exactly. We absolutely have to look at that. The overwhelming majority view in the scientific community is this is a comet. Maybe an unusual one, but a comet nonetheless.
And what's the official line, like from NASA?
Tom Statler, who's NASA's lead scientist for this kind of stuff, small bodies in the solar system, put it very directly. He said, quote, "It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know."
Okay, it does comet things. So what are those comet things that make most scientists confident it's natural, despite all the weirdness we just talked about?
The big things are the classic signs. It clearly showed a coma, that's the fuzzy gas cloud around the solid nucleus, and it developed a dust tail.
Ah, the classic comet look. Coma and tail.
Exactly. And the rate it was losing dust, how its overall path bent due to gravity, all that fits perfectly with what we expect from a comet, especially one ejected from another star system. It behaves, fundamentally, like a comet should. The basic physics check out.
Okay, so if it quacks like a comet, but what about the duck carrying industrial chemicals? How do they explain the nickel tetracarbonyl and Loeb's probability numbers?
Good questions. They tackle the composition first. Yes, the chemistry is, weird sources confirm it's like 87% carbon dioxide gas, only 4% water ice, which is very different from our solar system's comets.
So they agree it's unusual chemistry.
Oh, definitely unusual. But they argue it's explainable naturally. It likely formed way out in an extremely cold part of its home star system, maybe a dense molecular cloud where CO2 freezes readily, but water ice is less abundant. So, strange chemistry, yes, but not necessarily artificial chemistry.
They're saying nature can sometimes cook up weird stuff we haven't seen much before.
Essentially, yes. Complex natural processes might occasionally produce molecules like nickel tetracarbonyl, even if it's rare or something we haven't cataloged well yet in interstellar objects.
Okay, so rare but possible on the chemistry. What about the orbital targeting? That 0.005% chance.
That's where the debate gets a bit more technical, focusing on statistical assumptions. Critics, like scientists from SETI, argue Loeb's calculation assumes pure randomness in 3 dimensions. Meaning, they say, he's ignoring the bigger picture, the structure of the Milky Way galaxy itself. Most stars, and presumably any objects ejected from them, tend to lie within the galactic disk. So an interstellar object arriving roughly aligned with our solar system's plane, which is also kind of aligned with the galactic plane, might not be that improbable if you consider the galactic context.
So it's a debate about what baseline you use for randomness within our solar system versus randomness within the galaxy.
Exactly. They're pushing back on how low Loeb calculated those odds, saying the context makes it more plausible.
This whole thing really raises a bigger question about science itself, doesn't it? How does the scientific community handle a claim like this, especially from someone credible like Loeb?
Well, you get exactly what we're seeing. Intense debate and significant pushback. The standard in science is extraordinary claims require extraordinary proof.
And for many scientists, a coma and a tail is ordinary proof of a comet.
For many, yes. Our sources mention astrophysicists from places like Oxford and Penn State calling the alien tech theory absolute nonsense, basically saying you can't just ignore the obvious cometary features because of some statistical anomalies or weird chemistry. The burden of proof is extremely high.
Makes sense. But whether it's alien or natural, this thing is definitely giving us some amazing and frankly bizarre data. Let's dig into some of the weirdest details reported from telescopes like Stereo, SOHO, even the James Webb Space Telescope.
Absolutely. Some really strange observations. One was its color. Around perihelion, when it was closest to the sun, it actually became noticeably bluer than the sun itself.
Bluer? What would cause that?
It likely points to a very specific size and composition of dust particles in its coma. Maybe fine silicate dust scattering blue light more effectively. It's unusual.
And other chemical weirdness besides the nickel tetracarbonyl.
Yes. The Very Large Telescope in Chile confirmed detections of nickel vapor and also hydrogen cyanide, HCN. And what was weird there was where they detected them much farther out from the sun than you'd normally expect those substances to be turning into gas. They were volatilizing at surprisingly cold temperatures.
So more chemical mysteries. This object really is chemically exotic, no matter the origin.
It truly is. And, while scientists are grappling with nickel vapor and HCN, the public conversation got sidetracked by something else entirely.
You mean the Fibonacci signal rumor?
Exactly. This persistent rumor that started floating around social media about a mysterious signal, a pulse sequence, detected coming from the object's direction.
At 1420 millihertz, right. Which is kind of the magic frequency for SETI.
Precisely. 1420 millihertz is the frequency emitted by neutral hydrogen, the most common element in the universe. The thinking has always been, if an alien civilization wanted to send a universal hello, that's the frequency they'd likely choose, because anyone looking would probably be monitoring it.
And the rumored message was something like, observe, prepare, understand, the gate awaits.
Something like that, yeah. Total catnip for conspiracy theories and online speculation. Sounds like something straight out of sci-fi.
But let's be absolutely crystal clear here. This is not verified science, right? This is purely internet rumor.
Absolutely, 100% unverified speculation. There is zero peer-reviewed scientific evidence for any such signal being detected from 3 Aeolus. It's just hype feeding off the genuine scientific mystery surrounding the object.
Okay. Important clarification. It adds to the drama, but it's not part of the real scientific debate.
Correct.
So let's pull back and bring it to you, the listener. You've heard the arguments, the statistical near impossibility of that trajectory, the weird chemistry like nickel tetracarbonyl, the anti-tail.
Versus the clear presence of a coma, a dust tail. Behavior that, in many ways, screams comet.
So when you weigh all that evidence, where do you land right now? Natural but very weird comet. Or something else?
It's a tough call, and honestly, this whole episode with 3 Aeolus forces us to ask some deep questions. How should science deal with these really low probability, high impact hypotheses? What does it take to convince the scientific community of something truly extraordinary?
Yeah, what's the threshold for proof when you're talking about potentially finding alien technology? Are we maybe too biased towards natural explanations?
That's a valid question. And the investigation isn't over yet. There's a big global observation campaign coordinated by the International Asteroid Warning Network running through late January 2026.
And the James Webb Space Telescope has follow-up observations scheduled soon, right? December 2025?
Yes, critical observations. They could potentially nail down some of those chemical questions, really confirm or refute the presence and amounts of things like nickel tetracarbonyl and that high CO2 percentage. That could be decisive.
So more data is coming, but the clock is ticking.
It is. After 3 Aeolus makes its closest pass by Jupiter in March 2026, it's on its way out of the solar system for good. It won't be back.
Which leaves us with a final thought, something to chew on, really building on what the sources wrestled with. What has this whole intense debate taught us about our own readiness?
Yeah, are we actually prepared, scientifically and maybe even psychologically, if the next interstellar visitor leaves absolutely no doubt, if it's undeniably artificial?
Or will we keep defaulting to natural explanations, maybe missing crucial opportunities until it's too late to study properly? Something to think about. The deep dive definitely continues.